So our next topic is completing the square, and this is when factoring doesn't work. And in general, you're probably not going to use completing the square in the future, but it's good to know. So for our general equation, ax squared plus bx plus c equals 0, our steps are we first divide by a, subtract the constant term, which is c. Then we add a different constant so that the left-hand side is a perfect square. We're going to get into more detail about that. Then we take the square root, and there's a few details we also have to iron out. And finally, you have to add back a different constant, and you'll see which constant that is. So let's start with our first example, x squared minus 6x plus 3 equals 0. Our first thing is to divide by a, but a is 1, so we don't have to divide it by anything. The next one is subtract the constant term, which is 3. So we subtract 3 from both sides. We get x squared minus 6x equals negative 3. Finally, we have to add a constant so that the left-hand side is a perfect square. Well, how do we make sure that it's a perfect square? Well, we take whatever this term is, so this is minus 6, this coefficient, and we divide by 2, and then square it. So over here, we take negative 6, divide by 2, that's negative 3. We square it, and we get 9. So we have to add 9 to both sides. So we end up getting x squared minus 6x plus 9 equals 6. I mentioned that this is a perfect square. Now, which perfect square is it? Well, to find out, we just have to do the first step, divide by 2, and we get minus 3. What that minus 3 tells us is that this is just x minus 3 squared equals 6. Now, we go to taking the square root. So when we take the square root, we get x minus 3 equals positive or negative 6, root 6. Why can it be positive or negative? Well, if you square either, you're going to get 6. So if x minus 3 is negative root 6, you're still going to get 6 for x minus 3 squared. And same thing for positive root 6. And this is where our two solutions kind of come in for quadratics. Our final step is to add back a different constant term. What is this constant term? Well, we wanted x. So we're going to add 3 to both sides. Just get x equals 3 plus or minus the square root of 6. Now let's try a different example. 14x squared minus 8x plus 7 equals 0. So first we divide by a. In this case it's by 14, so we divide everything by 14. We get x squared minus 4 over 7x plus 1/2 equals 0. Now we subtract the constant term from both sides. We get x squared minus 4 over 7x equals negative 1/2. What's next? Well, we have to add a term so that both sides, this side is a perfect square. Well, we use our process over here. Divide by 2, square it. When we divide by 2, we get minus 2 sevenths. When we square it, we get 4 over 49. So we get x squared plus 4 over 7x plus 4 over 49 equals 4 over 49 minus 1/2. And from here, we get x minus 2 over 7 squared. This minus 2 over 7 comes from minus 4 over 7 divided by 2. And this side becomes negative 41 over 98 when you combine the denominators. And over here, we have a fundamental problem. Because we have something squared equals a negative number. That can't happen, at least for this class. So for here, we have no real solution.